Hi, hello everyone. Hopefully you can hear me clearly. Um, as Juan mentioned, I will be helping today delivering the first course on Make. Um, this is a very useful um, tool which can be used to um, parallelize pipelines. So you have a set of repetitive tasks. Um, you can write a short script that puts together everything that needs to be done in order to produce a set of results using dependencies, input files, and what output files need to be created. So hopefully through a set of simple examples, we're going to be building up towards a more complex setup that and hopefully you can see how it could be applied to other different situations. I think you should already have um, the website for the course. If not, I think Juan give you the link to today's course. Um, if not, I just put it quickly on the chat again. And this is the website that we'll be going through today. There is a section for a setup section where you are asked to download a zip file with some files within it. I'm assuming that some of you might have already done it. If not, uh, please could you let me know if you need time to download that file and extract it into your computer. I'll just quickly share my screen. Yeah. So so this is the website that we're going to with the content we're going to be working today. So in the setup tab, you come here. You have instructions of how to download some this directory. So please, if you haven't done so, please could you go ahead, click on the link, download that file, and put it in a suitable place in your local computer. Extract the content and open the directory. And once you have done that, I'll show you what you should have. Should see um, uh, there you go. This is the content you should see. Once you have extracted that file, you should see one directory called books with a set of Python scripts within it. And those are the files that we're going to be using today. So let me just now quickly go to my terminal. And for the rest of the course, that's what I'm going to be using. So some experience working with the terminal, it's would be very useful. If you have any doubts at any point, please do let me know if I'm going too fast. So hopefully you see my terminal now, and you can have the same content, one directory, and a bunch of 3 Python scripts. Now, if let me know if the font size is suitable, or if the color scheme is not It's not easy to see. I can change it quickly. Now let me go start with some with the actual content. So in today's lesson, we're going to be looking at some a simple example. So we're going to assume that we have been given these Python scripts and a hypothesis or some idea that we want to test, which is Sipp's law. And that law, what it states is that the most frequently occurring word occurs approximately twice as often as the second most frequent word. So that's enough any big enough text. So we have these three scripts that what they do is hopefully from the names you can guess. They count words in a text file and do some plotting, and then it tests that rule. They basically count how often the most common words appear in the text. So if I list the content of my books directory, you see here they have a few text files called abyss.txt, isles, last, and Sierra. So if we're going to be working with those files, well, we can have an idea of how they look if we quickly just use one of the our bash tools called head to print, for example, isles.txt. That shows that this is in fact a journey to the Western Islands of Scotland. This is a book. So it's a book, a full book in a plain text format. And what we're going to be trying to do is to count all the different words here and count how many times they appear, and see if we can find out if the law that we just have stated all actually applies to this book and others. So to run our scripts, we actually needed Python on our system. So hopefully we have Python. I do have my Python here. So I have Python 3.8. Other Python 3 versions should work as well. Not sure if Python 2 might work. I haven't tested with Python 2, but Python 3 should work. If you have any problem, please do let me know. So to run the scripts, what you need to do is do Python and then the name of the script, count words, for example. And then this particular script, what it takes, first argument, the name of the book, and then an output file that we're going to call the same name as the book, just that we're going to replace txt with that, and that will create a new file called isles.dat. And if we go ahead and type isles, we use our head command again to just explore what are the first lines. We can see that it has several lines of text in here. So the first column, it's a word, be, for example, then of, and to a. Then it comes the number of times that word appears in the text, and then what will be the percentage of that that word in the text. So it is organized and sorted. That's the content of our dat file. Moving on, we can do the same with the other text files that we have in our books directory. So if I repeat this, Python count words, and then give the first argument the books directory and the name of um, the book they want to open, this.txt, and then I just going to use the name of the text file, replace the extension with that. I can do the same process. You see now that more or less the apparently tends to be the most common word in both books. Not surprising, I suppose. So that's what our first Python script does, counting words. Now we have we have other two scripts. The next one will be plot counts, and what plot counts do is to actually help us visualize the words that we have just counted. So there are a few ways this script can do it. So the first one will be printing directly into our terminal. So for example, if I do Python plot counts, it will require the file where you want to get information from. So for example, isles.dat, and then it will ask you for, well, it expects you to specify how you want that information to be plotted. So it takes, for example, this argument ASCII, and what that means is going to print everything directly into the screen, into the terminal. So to do this, hopefully it will do some processing, and it will come back with this graph, or what it tries to determine is kind of an histogram of the level of how the magnitude of each word compared with each other. So you can see here, this is quite more prevalent than the next one, off, and then the next afterwards. And you can also show this in a more graphical way. If you repeat the command, for example, if I use my arrow keys to go up, if to my plot counts, instead of giving the ASCII argument, I give another argument called show. This will, instead of plotting into the terminal, what it will do is plot. It will open a window with that hopefully you will be able to see, or maybe not. No, I think you cannot see it. But this should open a window with with the same information, just more graphical. Hopefully you can see it. Please let me know if it doesn't work, if it is not working, any of this is not working on your side. I'll close it now. And the third way in which we can use plot counts is by providing a third format, which is if I provide a file name that ends in PNG, it will save the figure as a PNG file. So if I do this, now you will see that I have a new file in here called isolates.png. And if you were to open that file, you will see that that's actually an image, probably the same image that you saw in the previous step. So now this is the second Python script. So the third Python script, it's test Sipp .py, and what this script does is actually it tries to test, compares this first and second more prevalent word in the text file, and try to give us a ratio of from the first to the second one. So For example, if I try to run that script, Python test Sipp file, I will stop that. It will take the first argument. It will take is the text file or the dat file with the data to analyze, and then well, it will require a number of files that needs to be analyzed. So I can provide just one, or I can provide several. Like I have another one, I think that one. So I could provide two files or more if I had more. So and it will come back with this output. It will tell me, okay, for the first book, ISIL, the first word occurs 2,822 times, the second word 2,460 times, and the radius about 1.5 times. So the first one is 1.5 times more prevalent than the second one. And for Avis, it has a similar result. So our rule was that we were expecting to see about twice, so it seems to be not far from it. Of course, this is only two files. We might want to repeat this for other text files, other books, to try to get a better feeling if the rule that we're trying to prove actually works on a bigger scale. And now that you're thinking that that might you want to test more files, this might be taking more time from us. So it might be a good idea to start thinking of writing some kind of script. So the first thing that if we have some experience with Bash, the first thing we might want to do is use something like use Bash scripting. So let us open a text file called run pipeline. So in this at this step, you can use any text editor you want. We'll be using Nano because it's more user friendly. You can use Vim, you can use Emacs. You could also possibly use graphical based text editor if you want. For now, I will use Nano. And this will open this window of the text file for me to edit. So it is a good idea to start this script with some comments of what this file, how this file should be run, how we are expecting this to be run. It's a good idea just because if for our future selves, in case we forget how to run the script, to remind ourselves what to do, or if we want to share the script, some instructions can be useful. So so we're trying to remember what we did. So the first step was to try to execute our count words script, and that required a couple of arguments. So the first one was a text file to analyze, and then some output file where to save the result. Oh, there you go. Python count words by, and we did this the same for the next file. Once we had the dat files created, we wanted to plot some figures to get a better sense of how the data actually looks like. So the Python plot count py, and we do that again for every single that file that we just created. Yes, I think there is a question in the chat, or somebody raised their hand. Please feel free to unmute yourself, or perhaps put a question in the chat if you have a question.
Hello, can you hear me?
Yes.
Yeah, I think the second line should be books/abyss.txt, isn't it?
Right. Yes, you're right. And thanks for pointing that out. So it's actually it's not a planned error, but it will be useful because that will come out be highlighted later, and will actually be one of the reasons why doing a script using make over a script is one of the advantages. But yes, thank you for highlighting that. And then the last step, after we created the data files, the figures, the last step is we're going to try to, analyze all of our files with the test Sipp Python script. So for this, we provide all that files that we created, and we want to save that. Instead of printing the information into the terminal, we might want to redirect the output to a new file that we're going to call results.txt. And right, so I'm going to save this file. Now exit, and you have this file now here, which I can run by using my bash command, and then the name of this script. Hopefully it won't be any errors. And we should see now a new file called results.txt that we reanalyze the content. It should look very similar to what we had before. So, and yes, just that the abyss comes first this time, but all in all, it's the same results. Right. So that works quite well. I mean, in the sense that we can repeat those commands that we just printed before. Now the problem comes: what if we want to make some modifications to, I don't know, say one of our Python scripts? For example, say that we want to edit how our figures look like. For example, if we want to modify the width of our bars because we don't like them touching each other, maybe we want to make them narrower. So for that, we could open the actual script that produces the figures. So for example, let me use Vim this time. Plot counts, and so this is the Python script. And you don't actually need to go through all the Python script. I promise that this is the only time you're going to see Python during this lesson. There's a line here called in the plot word counts function, and that is called width, and that is the one that controls how those bars look. So if we say that we want to edit this line and we want to modify it to make it narrower, so now we just exit this, and then now we want to recreate those figures. So we could go ahead and retype bash run pipeline, and that will be fine. But just imagine that, say that the first just imagine that the first a couple of commands, these count words, were actually quite consuming. Then analyzing those the input files were actually very time consuming. taking I don't know, minutes, hours perhaps, and perhaps you don't want to do that. And you also know that you wouldn't need to do that because you didn't change anything in countworks, and the text files haven't changed. So idles, the data files wouldn't need to change either. So there would be any no need to do this. Save, and the only actual bits that you actually need to rerun is those commands that are that use plot counts. You will be right. So say that you want to avoid, rerunning these two commands. How will you do that? So in a bash script, the natural way to do it is either you can rerun plot counts manually, or using the script you could just comment them out for now and rerun the script just to run these two commands only, and that will be fine. But then it can be convoluted to remember what to comment at what point, and that's part of the problem once you start putting together a workflow with different steps within it. If at some point you made modifications to one of the steps, how would you avoid repeating running tasks that you actually wouldn't need to rerun because they haven't changed? So that kind of dependencies, tracking dependencies, figuring out what needs to be rerun and what shouldn't be rerun. That's something that Make actually help us with a lot. That's the whole purpose of this tool, Make, to automatize that dependency tracking and try to reduce the number of steps that need to be done to recreate our results. So hopefully that gives you the basic idea of what we're going to be doing today, and kind of give you the setup of the whole motivation. Please do let me know if anything is less than clear. We can try expanding on it. For now, I can probably move on to the next lesson, which is if I can, yeah, there you go. Actually, make files. Now we want to start now actually working with make files. So let me close this script, and I'm going to open a new one, a new text file, and I'm going to call it makefile. And this is not coincidental. So this is a convention. So Make by default looks for files called makefile. If it finds one within the directory where you run the command make, it will try to process its contents by default. There is also a way to change that behavior, but for now we're going to be using that name. So if we create this text file, make file, and let us start putting some content here. So the first in makefile, the makefiles, the comments are very similar to those from Bash. So you can start a hash. You can start a line with a hash symbol, and that will be treated as a comment. So this would be a comment. And then we're going to be looking at the actual syntax of a makefile. So, and then I will explain in a moment what these do. So a line like this, it's the grammar. Say it's you can see this colon in here, symbol. What it does is what it comes before it. It's called a target, and what comes after, it's a dependency. And then the next line, you need to insert a tab symbol. But it is important. It needs to be a tab symbol, not the spaces. and then comes what the rule for that target. So what it needs to be done for that particular target. So in here, if I specified, and I will show you how to specify targets in a moment. If you specify this target, isolist.that, make will find this rule, and then it will know that this particular target requires these dependencies to work, and it will know that these actions need to be taken. So we can save this file for now, like this, and you should have this file in your directory. Let me just clean a bit everything that I created up to now. So I will just remove all the DAT files that I just created and all the image files. Just be careful when you're using the remove command. Just we want to avoid removing everything in your directory. So not that it has happened to me before. So now I only have this my Python scripts, in my previous bash script from pipeline, and my results.txt. So if I run make, as I mentioned before, it will look by default by a file called makefile. So I don't need to specify anything else. And it says there is no rule to make target books idols.dat. Let me see. What is that? So let me. Right. So if I, let me just show you why. So I made a typo here. So when I executed make, so it found my make file, it scanned through it, and found that the only target available was isolist.dat, which is fine. And then it looked for what dependencies were needed, and it found that it required books idols.dat, which that file doesn't exist because it's not a .dat file. It should be a .txt. And that was what make was trying to tell me, that file didn't exist and there was no rule to create that file. So for now, let me just change that, save, and run again. So now you can see that make run successfully, apparently, because there was no error message, and it executed this action, this command. So run python converts to py books idols.txt. So if I list the content of my directory, you can see now that I have this file, and if I explore the content, you can see that it's very similar and actually should be the same as we had before. If you're getting any error, but something along the lines of missing operators, separators, you might be using space instead of tabs. Something that is very common. It can be confusing. But if not, if you're getting actually this file and seeing this content, we're in the right track. As I mentioned, they can be you can name the make file, give another name, and tell make to use that file instead. The way to do that is in the training material. You can see the details there, but basically what you should do is specify this -f argument, this flag, and then the name of the file, like my other makefile, and that will they'll make to use that other makefile instead, not the default makefile one. But for now we're going to be using just the default. Right. Now, if I run make again, make doesn't actually rerun the action, doesn't run the Python script again. It actually tells me that isles.dat is up to date, doesn't need to be recreated. And you can see here now that the first advantage, make actually keeps track of what needs to be done. And if you ask it to try to rerun the command, it will tell you not that you don't need to do it. There's nothing to be done here. It's up to date, which is good. Now, how is possible that make does this? Is by make, what it does is it keeps track of the timestamps of the files. So if you long list your directory, you can see here that there are some timestamps of when a file was created, and that's basically what make checks before trying to run an action. And if it says that that idles.dat is newer than the makefile, then we'll say no, that is newer, so it's up to date. So let us try to change that. Say that I want to, if I say that I did some modification on my input file, in this case a text file. I added some lines or did some other kind of modification, and I can mimic that by using this command touch. That the only thing it does is it updates the timestamp. That's the only thing it does. So if I do this again, you can see now that, oh well, you won't see it because I didn't list books, but you can see now that I just changed timestamp here to now. So if I hit make again, you can see now make actually rerun the command, because now it says that one of the dependencies, text files, in this case the text file, was newer, meaning that was recently changed, and therefore the output file isles.dat, the action to create it, needs to be rerun. So that's kind of the idea. And hopefully that's clear. Right. So now we can start, trying to make it, adding more lines into our makefile. So let us open again, and let me add another one. This time for the other file that we were working with. So abyss.dat. So this one requires abyss. The dependency is this input file, and the action that needs to be taken is python downwards.py. And this will create a file that. I think there was a question in the chat. Just does that mean that if the target file was created after the last save of its dependency file, the make will launch the rule? Yes, that's more or less the idea. So make is clever enough to see if any dependencies have changed for a given target, then it will relaunch the action. That's the idea. And if nothing has changed in the dependencies, therefore the action shouldn't need to be rerun. And okay, we have our first scripting error. That is I cannot see right from the get-go what that might mean. I don't know if one of the helpers could take a closer look while I save this file. So hopefully so now I have two targets in my make file. Right, I have two targets in my make file. So if I run again make, it tells me that isles.dat is up to date, which is, yes, it is, but I also wanted it to create an avis.dat file, which is not doing. Which I should want to. So the problem is that by default, make has a default target. That will be the first one that appears. In this case, idles.dat. If it finds that one, it will execute the actions, and if there's nothing to be done, that will be the default answer for make. It will find the default target, say that nothing needs to be done, and come back with that reply. But we can force make to actually run the target that we wanted by specifying the target by name. So in this case, make avis.dat, and that actually will tell, okay, make, I want you to run the actions for this target, and that will, okay, yes, I do have a target with that name, and I have an action for that target, and it will run it. Now, if I run it again, we get expected output. There is, it's up to date now. Nothing to be done. There is actually a difference between the messages that we might get from make. So, for example, if I do make count words by, you get a different kind of message. It's not really an error message. It's more like an informative message. It says nothing to be done for count words.py. And if you didn't know what the content of the make file was, you wouldn't be sure what that means. You know that there is no target count words.py, and there is no rule for it either. So the difference between nothing to be done and up to date is basically that, as the message says, count words, what it says, it has no rule for it, and therefore has no actions, and that's what the message says, nothing to be done. And the other one is up to date, says that there is an action, there is actually an action there, but it doesn't need to be run. So that's kind of the difference, and two very common messages that you might find. So there's another question in the chat. Oh, yeah, thank you for replying. So, and another very common action, another very common target that you will find in make files is a clean target. So if I open my make file and I keep adding targets, I can add this one. And again, don't forget that these are tabs that you need to add. So I can do this, and so this target, well, it doesn't have any dependencies, doesn't require anything to be executed, and it will just run this command. It will remove forcibly, meaning that even if it is not there, it won't throw an error or warning any DAT files that are present in my current directory. So save this. I can do make clean. Well, before that, let me just save the, at least the content. So I have this dat files, abis and isles.dat. So if I do make clean, it run this command, and my dat files are done, which is okay. That's what I wanted. I wanted to clean my directory, which is okay. Now the problem is, I have a target, that if it doesn't have dependencies. Say, what happens if you have let me just yeah, I think the question that was in the chat was about if we can run multiple targets with make, and kind of we have an example. The next example is exactly the answer to that. Yes, we can run multiple targets. For example, if I want to rerun my isles.dat and my abis.dat, so I want to run these two targets, and you can see, yes, it will run the actions specified for each of those targets. Now, say that you have a directory called clean here, and what happens if I try to now run my clean target? It was like clean is up to date. That's not what I wanted. I wanted to remove my dat files. So the problem is that it will find the because it is finding that directory within your current directory, which finding a file with that name, your current directory, it will assume that that target is related with recreating that file or directory, which is not the case. So there is a way to solve that kind of situation. So, and that are phony targets. So instead, I can tell make that this target needs to be run regardless. So every time I specify that target, it will need to be run, which is kind of what we want. Even if there is a directory matching that target in our directory, doesn't matter. Don't check if the timestamp. Just run the target. And there's another problem. So it seems like my makefile run only the first row. Did you specify both isles.dat and abis.dat? So now, if by adding that line, that phony target, if I now do make clean, you can see that now make actually will run that target independently if there is a file or directory with that name, the current directory, which is okay. And we can add other types of phony targets like that. So, for example, if I don't want to specify every single target, like for example isles.dat and abis.dat, I can add another one, for example, called phony dats, and I can say dats. So this target, this is the name of the target, and the dependencies of the target will be isles.dat and abis.dat, with no actions to be taken. So this is the important part. So what will happen is that because it's a phonic target, this target will be run every time that I specify it specifically. And because it has these two dependencies, make will look for rules for those dependencies, and it will find those rules within the make file. So it will find that there is a rule for islets.dat, which is this one, and there is another rule for avis.dat, which is this other one. And it will look within each of those rules and say, has a dependency on this text file and has a dependency on this other one. And if they need to be updated, it will update them. If it doesn't, it won't. So let me, hopefully that's clear. Let me know if it doesn't, because now we're actually starting to work with dependencies. So if I do make that, now I am specifying that phony target. You can see here that it will run it, which is fine. If I try to do it again, it will say nothing to be done for that, because this time what it did was keeping track of the dependencies of that. That depends on islets.dat and avis.dat, and those rules. Exploring those rules, it might realize that now those files don't need to be they don't need to be updated. So again, after exploring all the dependencies, we'll come back with the answer that okay, no, I don't need to do anything for that target. So hopefully that makes sense. Please do let me know if it doesn't, or think maybe you need something else more thoroughly explained. So that in the training material, if you're a bit behind, there's a link to the actual make files to the make file up to this point. You can download and continue from that point. So you just need to go to the material, and near the end, before the something that looks like a schematic of the dependencies, you can find the link in there. Here's another question. No. The question is if a phony target, if it needs to be a phony target in order to have multiple dependencies. And no, what a phony target is basically, it just tells make that what you want. What it makes it a phony target is that it will be run every time. It won't look for if that specific target it's already up to date or not. It's not about the number of dependencies that it has. It can have one or can have many. But what it make it funny is that it won't check for that timestamp, and it will run it every time. So hopefully that makes sense. Let me move on to the next topic. I think I still have a few minutes to cover the next one before the break. With automatic variables. So let me open again my make file. So it looks like this at this point. So the next problem is we have a bit of duplication at the moment, and we would like to actually oh no, sorry, sorry, there's an exercise within the training material, which it's about writing 2 new rules. So it might be a good idea to go through that exercise. So I wonder if you want to go ahead and try to solve it. I'll show you if I can in hopefully, there you go. Hopefully you see this this exercise in here, which is in on the makefiles section. Scroll down. So near the end, there is this final exercise for this section, which is asking us to write a new rule to process our last.dat based on another book in our books directory called last.txt. And we want to update our that's phonic target with this. We want to update that rule, and we want to create a new rule for to create a results.txt file with a summary table. And obviously that rule needs to depend on every single dat file that we want to analyze, and needs to invoke an action, and the action is in here. And we want to put this rule at the top of our makefile so that it becomes the default target for rule. So hopefully after what we have seen, you're in a good position to give it a try. So I'll give you a few minutes to do this. I don't know what would be best. Should we review that after break, or for the break?
Yes, I think we can see the solutions after the break and give this time to practice with the make.
Yeah, I think that makes sense. So should we rejoin at 11:30 then?
Yes, so yes, let's do the exercise now until 11, and then we'll have a half an hour break. We'll come back at 11:30.
Great. So we'll be around here, well, during the break. But if during trying to run the exercise you run into any problem, please, we'll be around here to help you out. So right. So please just give it a try, and then from 11 to 11:30 we're going to be in a break, and then at 11:30 we'll come back.